The next two problems that I'm going to do are two different types, but they are one type that we've already addressed with just one additional step, and then another one that's a very, very easy type of problem to do. So we're going to do two types in one video. It'll be a very short video for these two problems. So on question 10, the only thing you really need to remember is that when you see cosine squared of theta is equal to 1/2, that is the same thing as saying cosine of theta squared is 1/2. Okay, and so in order to get cosine by itself, all you need to do is square root both sides. Now that does require that you remember a couple of things. The first thing, of course, that you'll have to remember is that when you square root to solve, you need to plus or minus. And then the second thing that you're going to need to remember is how to take the square root of a fraction. And so the square root of a fraction is just the square root of the numerator, which would just be 1, and the square root of the denominator. But of course that number is not going to show up on your unit circle in that format. You would have had to rationalize it. And so the way that it will show up on your unit circle is as square root of 2 over 2. And so once again, this worksheet is only answering for thetas from 0 up to 2 pi, but of course not including it. And so now I just want to know what angles on your unit circle have that cosine value. And so you're actually going to have 4 answers, because I want to know where is cosine positive square root of 2 over 2, which is here and here, or negative square root of 2 over 2, which is here and here. So you're just going to list all 4 of those answers. So pi fourths is the first angle that has one of those cosine values. 3 pi fourths, 5 pi fourths, or 7 pi fourths. And so those are the 4 answers to number 10. Okay. Number 14 is the next one. And before I actually write out number 14, I just want to remind you that once again, on worksheet 4.2.1.b, you guys did problems that said things like secant of theta is equal to 2. And the way that you solved those was simply to do a rewriting step. And so you would have said if secant of theta is 2, then that means cosine of theta is 1/2. Okay? And so all 14 does is it combines this notion about needing to rewrite as a reciprocal with the types of problems we did on number 6 and 8. And so we have secant of 2 theta is equal to 2. So the first step would be to rewrite it as cosine. If secant of your angle, does not matter what your angle is, but if secant of your angle is 2, then that means cosine of that same angle would be the reciprocal of that, which would be 1/2. So now we do our inverse cosine step. We answer the question, which angles have a cosine value, of 1/2. The first one is, of course, pi thirds, and the second one is 5 pi thirds. But of course, from our previous problems, we know that that 2 right there is going to be doing a horizontal compression to our function, and since our function is now going to have a cycle that's half as long, it's now going to generate twice as many cycles or twice as many answers. And so we will need to write these 2 answers in general solution form, because our last step is going to be to get rid of that 2, which means we're going to multiply through by 1/2. And multiplying through by that 1/2 will not just impact these 2 initial answers. It will impact the period length between answers, or the frequency with which we generate answers. So when we multiply through by 1/2, theta's by itself now. The pi thirds becomes pi sixth. The 5 pi thirds becomes 5 pi sixth. And then the 2 pi n's both become pi n. And so that tells us how far we're going to have to cycle to our next answers. Okay, now I'm just going to go ahead and proactively go ahead and change these pi's right here to be 6 pi over 6, because 6 pi over 6 is still pi, and because now they have the same denominator as their original answers. And so now we can generate our final list of answers between 0 and 2 pi. So our first general solution gives us pi sixth as the primary answer. If we add 6 pi sixth to it, we get 7 pi sixth as our next answer. And we don't add any more, because the next one we would have added would have become 13 pi sixth, which is bigger than 2 pi. So these two answers are the two answers from our first general solution. And then the second general solution gives us a primary answer of 5 pi sixth. And then when we add 6 pi sixth to it, we get 11 pi sixth as the second answer. And then we're done with that one as well. And so there's our 4 answers. And once again, we knew going into it we were going to have 4 answers, because this equation right here, had it not had that, we would have normally generated these 2 answers and been done. But because of that 2 theta that was in our trig function, we knew we were going to generate twice as many answers, which we did. And that's all that I did to wrap up. These were actually the last couple problems that we did on Thursday in class. We didn't actually do number 12. We just discussed that it's really just a compilation of these different types of problems. So, of course, the first thing that you would do is you would divide by 3. And then the next thing that you would have had to deal with is you would have gotten rid of the squared, so you would have square rooted both sides, and then you're going to rewrite it so that you can not have it in terms of cosecant. And so when you get to that step, you just need to remember that cosecant and sine are reciprocals of each other. And then of course you guys can always let me know if you need me to actually work through this the rest of the way for you.